This is HL paper 3 question 7, which is all about the photoelectric effect. It asks you to initially state two experimental observations other than the existence of a threshold frequency, and that's an important point, that led to this conclusion about wave theory. So there are four possible things that you could have said. The first one is that the frequency is what determines the maximum kinetic energy of the emitted electrons in this effect. The second point is that it's instantaneous. You don't have to wait for a certain amount of energy to be received in wave form. That indicates that there's a packet of energy that arrives at one point, the photon. We also know that the intensity increases the number of electrons that are emitted, but does not increase the maximum kinetic energy. And that's because intensity is essentially the energy per unit area, per unit time that's arriving. So if you increase that, you're essentially increasing the number of photons of a particular frequency. Okay? If you're increasing the number of photons, that increases the number of electrons that are emitted. But there'll be more on that in the next part of the question. It then says monochromatic light is hitting this surface here, and the surface of the metal has got a work function of 2.4 electron volts. It's really important to note that that's EV and not joules. It asks us to calculate the threshold wavelength, not the threshold frequency this time, but the threshold wavelength. So the equation that links these things together is HF, the energy of the photon that's arriving at the metal surface, will equal the work function, the minimum energy to remove the electron from the surface, and then any extra energy will be the kinetic energy of the electron. Now, because this is asking us for the threshold wavelength, we can let EK equal 0, so it cancels out. We're also asked about the wavelength rather than the frequency, so we can actually say hc over lambda is equal to phi, where that's come from this, the wave equation. We've replaced f with c over lambda. That means to get lambda, we just do hc over phi, so we've got our numbers here. The only important thing to notice is that I've had to multiply the 2.4 electron volts times by 1.6 times 10 to the minus 19. That's the number of joules per electron volt in order to get 5.2 times 10 to the minus 7 meters. Whenever you see this, you must use standard units of joules. Brilliant question at the end of this, asking about state and explain the effect on the current that's produced in the photocell for the light incident on the surface of a wavelength that is less than a half of lambda s and the same intensity I. So basically, if the wavelength is decreasing, that means the frequency of each photon is increasing. If the frequency is increasing, HF is increasing, which means the energy of each photon is increasing. Therefore, in order to keep the intensity the same, less photons need to arrive at the surface. If there are less photons arriving, that means less electrons will be released. If less electrons are released, the current will decrease.